Architecture for GATE Computer Science syllabus. My name is Vishwadeep and I am here to teach you Computer Organization and Architecture course COA. So this particular COA course is having a really good weightage in computer science GATE examination. So you need to work to learn this particular course and you will have to come live in all the sessions to learn this particular course. Today, what we are going to discuss in this course is the basic fundamentals of computer. Very basic things we are going to start with. Basics of computer system, that what basic things you should know before you will go about or you will learn about exactly how the computer works and remaining other things about the computer organization and architecture. So first of all, let me tell you a few things. If you are here and watching this particular lecture live, then just like the video. As soon as possible, you join the video, just like the video, so that your attendance will be marked. Attendance, yes, of course, attendance is really required. So the very first thing you need to do is mark your attendance by liking the video and subscribe this channel. Why? Just because you are here means you are a learner. You want to learn few more things about computer organization, not even this course. You want to learn lots of things about this GATE computer science syllabus. So all the subjects, all other information regarding the channel will be available on the channel. Hence you need to subscribe and you need to keep the notifications turned on so that every single thing you will get to know, any announcement, any new batch, any new subject, any new course, anything comes on the channel, that will be notified to you as soon as it will be live. Okay, so everybody here who have joined here, like the video and subscribe the channel. Like the video and subscribe the channel. Everybody who have joined here, very good evening. Like the video and subscribe the channel. We are going to start with this particular topic today, basics of computer system. First of all, let me introduce myself. Before that, here is a really good motivation quote for all of you to start a course, new course. डर मुझे भी लगा फासला देखकर, पर मैं बढ़ता गया रास्ता देखकर, खुद ब खुद मेरे नजदीक आती गई मेरी मंजिल मेरा हौसला देखकर. If you can't understand Hindi, let me translate it. Initially, I was afraid. Why? Just because from my current stage to the destination, the distance was very large. It was too far. The destination was too far. But I started stepping towards the destination by just looking at the way, the path I was just looking at, and I was going and going and going. And slowly, what happens? The manzil, the destination started coming closer towards me when the destination was just looking at my courage. So my courage was so good that my destination was automatically coming closer to me. That's the motivation. So I know this course is very tough. You also know that course is very tough. You need to work hard to learn lots of small concepts in this particular course. So what you need to do, you need to keep the courage, you need to keep the patience, you need to you need to have the continuity. If you all will have that, then definitely you will learn this particular course with very ease. Yes, correct. Now, okay, next thing is this. My profile, my name is Vishwadeep Gothi. Most of you know about me. If you don't know, then okay, let me get you more information about myself. I have given GATE exam multiple times in computer science. My this is the highest rank I could get in 2010, which was my fourth year of engineering. Yes, in my fourth year of engineering, I could get that much of rank. And then before this, I have written GATE exam in third year also, and I was having the rank 682. And then apart from that, I have written the GATE exam multiple times, 119, 440, and there are so many other ranks I am having in the GATE. I did my master's IISc Bangalore, and apart from that, I am having another MTech. Yes, you heard it correctly, another MTech in data science from Bits Pilani, and this is just this year only I have finished it in the data science. You all know that the data science is very highly trending technology nowadays. Hence, I just learned it for my understanding, for my own understanding, for my own learning. I was very curious कि ऐसा क्या है इसमें. I just learned it. I'm having overall 13 years of experience, in which 9 years only for GATE. And these 13 years of experience is teaching only engineering students. Yes, only engineering students, no any school student for me. And these are the courses I used to teach for you guys. Computer organization, just now I started. Data structure, I'll be teaching immediately after this or as soon as possible. But definitely I'll be teaching here on YouTube also and on Unacademy Plus also. Apart from that, I will help you with this specific course also, coding interview preparation. All those tough problems of coding interviews which are mandatory for you guys in the preparation of really high-end interviews. High-end interviews means like Amazon or Microsoft or Google or maybe Facebook or Apple or whatever tough interviews questions you are having. I will help you guys to solve those problems, to understand those problems also. Any person who wants to join Unacademy Plus can join Unacademy Plus by using this code. VDeep10 is code. If you use this code, you will get 10% discount. And what are the benefits? The benefit of using Unacademy Plus are these. बहुत अच्छे हैं. There are so many good benefits. One, live classes. Definitely, these live classes are very interactive. You can't even imagine. If you have ever taken any class on Unacademy's special classes, then you can understand, yes, these live classes will be more interactive and of course more learning or more engaging. Both the language batches we will be having over there, English and Hindi. Other than that, every fourth class we conduct there as doubt clearing session. Yes, so after every 3 class, I used to conduct 1 class for doubt clearing. So whatever 3 classes have happened, for whatever those problems you had as a student, of course you will have definitely doubts in this specific course. All those doubts will be cleared. Then weekly test, those quizzes are also again very important. Then crash courses we will conduct at the end. ये बहुत जरूरी. This is very important. Why? Just because, see, you also face the problem that how to revise the things, when to revise, how much time to take, how to revise, what are the things we need to touch, what are not. All those things are our responsibilities. We will conduct special batches once the entire course is done on the Unacademy Plus. For the crash course means, in the fast track way, we will cover all the syllabus in a better revision mode. So then we will be having some rank improvement batches also. As of now, for computer science, no any rank improvement batch, but soon we are going to launch. Okay, so if you want to get the subscription, if you really want to have really good rank in GATE, then don't wait, just click on this button, get subscription. I am telling you, the person who think like I can learn from YouTube, I can learn from different sources and I can break the GATE. Yes, possibility is there, but probability is very less. Possibility is there, but probability is very less. Yes, around only 5 to 6 students, 4 to 5 or 5 to 6 students among 1000 students can get this particular thing done. That they are very punctual, they are joining the classes regularly, continuity is there, and they are learning every single thing, understanding every single thing, and then they can crack any kind of competitive exam with the highest desired rank. If it is possible, yes, possible, but probability is very less. So if you are not among those, then you need to join something which is more engaging, more continuous, more organized, more structured for your learning. And this is the thing. Get ESE, just pick the goal, get the subscription, just click this button and go for the subscription. It's not too much financially, I'm telling you. Really, it's not too much. It's very less amount. If you'll go for one year of subscription, that's 25,000. But if you'll use my code VDeep10, you will get 10% of discount. You'll get 10% of discount, and That will be just this much, and it's just 40 rupees per day, which is not too much. And this 24 month subscription, if you are taking 30,000, it is, see how less it is, how less it is, yes, very very less. And if you will be going for this one, see this 27,000 after the discount, and which is nothing but 60 rupees per day, that's it, even lesser than that. So it's really really beneficial. You will get unlimited content of every subject. Every subject is taught by multiple faculties, and there are so good contents over there. So don't think about it, join it. Payment option, you all are aware of the payment option. You can go for EMI option with credit card, or you can go with the HDFC debit card and Bajaj debit card also for the EMI option. Yes, debit card also can provide EMI option to you guys, but you need to use this code VD10 so that you can get 10% discount. Okay, so these are some social media channels you can follow here. This is the Unacademy Computer Science channel of YouTube you are following. You can recommend other channels also of the team, which are, or like you are having friend in electrical, electronics, or mechanical, or civil, or SSC JE preparing aspirants you have, then just recommend those people to join our channels. Okay, so let's begin. Fine, I'm reading so many questions from you guys. Yes, 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 yes. Definitely, I'm going to cover entire COA syllabus here too. Don't worry about it. If you are not able to join the Unacademy Plus, then it's fine. I'll be covering entire syllabus here too. So let's start with this. But before this, I want to tell you few things, that what are the prerequisites for this course. What are the prerequisites for the course? Prerequisites are what you should know before you can learn this course. Okay, so first thing you should know about is the number system. Yes, number system should be known. What is number system? Number system is very simple thing: binary, hexadecimal, and how to convert these to that. And signed magnitude is what, one's complement is what, two's complement is what, how to convert 10 into binary and then binary to hexadecimal or something like this. All these number system, if you know, that will be better for you. Then after that, you should have some knowledge of uh, digital logic basics. So only basic things I will require for this particular course. What those digital logic basics? Those digital logic basics cover that logic gates plus. So logic gates you can have. Of course, you are having the knowledge AND gate, OR gate, XOR gate, XNOR gate, and all other things. Then apart from that, you should have a little bit knowledge of how a decoder works and how the multiplexers work. If you are fine with this, then this particular course will not be tough for you guys. If you are not fine with this, then hardly one day it will take to revise all these, that how is a decoder working, how a multiplexer works. You just revise these things, brush up those things, and you will be fine to learn this specific course. So these are the prerequisites about the course. Let's go further and let's start. First of all, let's see the difference between computer architecture and computer organization. So computer architecture is the definition conceptual design. Okay, so it's a conceptual design only, not actual design. Okay, just the conceptual design and fundamental operational structure of a computer. Now, this is the technical definition. Of course, everybody cannot understand technical definition. So let's understand the actual meaning of this definition. If suppose I am a designer, I am an architect of a new computer system, then how I will design a computer? How I will design? First of all, I'll decide. First of all, I will decide that what type of system or what type of devices I'll be having in my system. That I have decided that I am going to have I am going to have one CPU in my computer system. Then I have decided that I am going to have one main memory in the system. RAM, ROM or something. And then I have decided that I'm going to have IO devices in my system. So what exactly I'm doing here, I have just decided that what kind of devices I am going to use in my computer system and what is their operation. Why I am going to use memory, I have given this. Why I am using IO devices, what is their functionalities, what is their operations, I have given this. Why I am using CPU, what is their functionality, what is its functionality, that I have given. Now listen, it is very important now. It is very strange now. What is strange? If you are saying that my CPU can perform these functions, means these operations, which means ultimately you are giving my CPU's instructions, that what type of instruction my CPU can support, what type of instructions my CPU can support. So what happens in that case? What happens in that case, that if you are giving the computer architecture, of course you are giving what type of devices you are going to use. Then in those devices, what will be the different devices working, means what memory works for, what IO device works for, what CPU works for, what is their operations. And other than that, what you need to give in the detail is your CPU's design. Your CPU's full design you will have to give. Now what is this CPU design? What is the CPU design? If you have ever heard about 8085 microprocessor or 8086 microprocessor, I'm not asking you to recall every single thing. Seriously, I'm not asking you to recall everything ki kya tha, kyun tha, kaise tha. I'm just asking you if you have ever heard about such kind of processors. Their processor design is given theoretically, right? This is the processor, this is the block diagram, this is the pin diagram, and this is the working the thing, and so on. If you have ever heard about such kind of things, that is CPU design. So theoretically, I'm telling about again this, okay, conceptually, theoretically, my architect, whoever is designing a new computer, should give the CPU design. And in that CPU design, two things are given internally. One thing is instruction, one thing is instructions, and other thing is addressing modes. Now, believe me, I'm telling you this particular thing. Believe me, this course is kind of, or learning this particular course is kind of a watching a thriller movie. Why I'm saying this? Just because you cannot know all the suspenses in the first half or in the first few minutes of the movie itself. You need to watch complete movie to know all the suspenses, right? All the suspenses will be open, will be unfolded slowly once the movie goes on. This is exactly same thing. If I'm talking about addressing mode, if I'm talking about instruction, you need to wait exactly for what, for unfolding of those topics. Whenever the time will come, I will tell you exactly what instruction is, I will tell you what addressing mode is. But just wait for that time, wait for that particular time. Why? Just because right now if I'll explain you also, then everything will not be clear, and my time, your time will be wasted. So just think about this, that CPU design is given in the computer architecture, along with that instruction is given, addressing mode is given, and along with that data format is given. क्या होता है ये? What is this data format? In a while I will explain. In a short while I'll explain. So these three things along with the CPU design given in the computer architecture. Now see, you have just given the basic detail, that this is the concept, this is the concept of my new architecture. You have not implemented, you have not implemented it. When you will try to implement this concept, then you will switch to where? Then you will switch to where? You will switch to next one, this organization. You will switch to organization. You will switch to what? Organization means it's an implementation. I can write here, it's an implementation of what? Implementation of computer architecture. I hope you guys are clear about this. You need to type down if you are clear or not in the chat box so that I can understand. So that I can understand if you are understanding or not. You need to type down in your chat box that you understood whatever till now I explained. Immediately, write down immediately that did you understand it or not. Come on. Okay, so I'll wait for your answer. Till then, I'll explain further that what happens in the organization. We try to implement the computer architecture, which means it deals with the physical devices. Devices means actual implementation of your concept. You have made the physical device. You have made the memory. Memory means you can decide. While implementation, you can decide your main memory will be of what type. It will be byte addressable or word addressable. Anything, your implementation, your decision. It can be like you are implementing the memory with semiconductor based memory or something else. If you are having the addressable memory or associative kind of memory. So every single implementation details come in the organization. It comes in the organization, right? It comes in the organization. Now see how organization says, what organization says, it deals with physical devices means implementation and their interconnection. Abhijit, this is very important point, boss. This is very important point. Why? Just because previously I told that this is the device, this is the device, this is the device. Now I am telling you that how these devices are communicating to each other. How these devices are communicating to each other means if CPU is there, if CPU is there and if memory is there, how CPU interacts with memory, how CPU interacts with IO device, how IO device interact with memory, all these interconnections will be given by what? Will be given by this organization. This organization detail. So this is CPU, this is your memory, this is IO device, all these are interconnected. And how this interconnection works, how this communication works, but that communication I'll have to implement with this perspective in my mind. What it says, read it with the perspective of improving the performance. Means you, suppose you are an architect, you have started implementing one particular computer system. So you have taken an architecture, you have started implementing it like this, and you are saying what? You are saying that my CPU is communicating with memory, my CPU is communicating with IO, memory is also communicating with IO. Now you need to implement this communication in such a way that the performance of the system can be improved. But the performance of the system can be improved. Why? Of course, yeah, it's very simple thing. If performance is good, user is happy. Performance is good, customer is happy, end result is good. So how you can implement such kind of things? You all know this answer. How I can give the faster access of the memory to CPU? How I can improve the performance of memory access? Answer is very simple. Use the cache memory. So use of cache memory means what type of decision? Architectural decision or organizational decision? I want your answer here typed in the comment box. I want your answer. Is it architectural decision or organizational decision? It is organizational decision. That how CPU and memory will communicate and how we can improve the performance of memory access. And answer, your answer is what? Cache memory use. If I am saying CPU is using IO access, then how we can improve the performance? We will learn this also after some time in next few chapters in IO organization chapter, that how fastly or how with better performance CPU can access the IO or CPU can have the IO interaction. Answer is interrupt mode. I'll explain you how it happens. You might not know that why interrupt is good, but I'll explain you that too at that time. So suspense is not yet over. Keep suspense in your mind. Keep the suspense in your mind. Be till there. I will explain you this also. I will remember on behalf of you कि मैंने पहली क्लास में, in my first class I talked about this. So you remember this. You remember this. I will explain you that time. And another thing, if suppose IO device wants to access memory directly, can we improve the performance here? Yes, 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 yes. You know the answer. We can improve the performance by using the DMA technique, direct memory access technique. Right? So organization says that we are implementing the actual architecture's concept into devices. We are implementing the CPU. We are implementing the memory. We are implementing the IO. We are implementing the interaction between all those devices. And at last, most important point, while they are communicating, we are improving the performance also. So till now, if it is clear, just write down that you got it, everything is clear so that I can move further. Are you getting it or not? Just let me know so that I can go further. Fine. So if I will talk about, it will be kept on YouTube. Don't worry, it will be kept on YouTube, but I want everybody to learn this course live along with me. If you will not learn live, there will be so many doubts unanswered and difficult to answer later on. We can have channels to discuss, but still I'm telling you, if you are not coming live, then learning this specific course without interaction in the recorded session will be difficult. For revision purpose, of course, this lectures will be available online. Fine. So I was talking about what are the things included in this organization. In the organization, the things included are, first of all, how IO devices are organized. So IO organization is included. Second thing, second thing is what? Second thing is how memory is organized. So memory organization is included. And the third thing is performance improvement. How the performance can be improved. All these things are included in what? Organization. वेरी गुड इवनिंग एवरीवन, वेरी वेरी गुड इवनिंग, वेरी वेरी गुड इवनिंग. चलो बाकी सारे लोगों को भी जल्दी जल्दी लेके आना, यहाँ पे लाइव लाना जरूरी है. एवरीबडी शुड बी लाइव हियर टू लर्न दिस कोर्स. सो मेनी पीपल वेटिंग फॉर दिस कोर्स सिंस लॉन्ग. Now if the time has come, you should be live per day on the regular basis, then only you can learn this course. I'm telling you seriously, I have taught this course for 9 years, more than 9 years in fact. Before engineering, I mean during the engineering also I taught this course, and I know seriously it is very very tough to learn this course. So you need to be live, you need to be attentive, you need to be continue in the learning. Okay, so all these things I have already written. I have given you CPU design, done in architecture, instruction included in architecture, addressing mode included in architecture, data format included in architecture. Organization has IO performance, IO organization, memory organization, and performance of the system. Now, what is this data format? Let's talk about this. Let me add a few page and I'll tell you what is data format. You all know that in my computer system, we store the data in binary only. If you all know, that's well and good. If you don't know, then aaj pata chal jayega. We store every single type of data in the memory in the binary format only. If that is the case, what type of data you store? For instruction execution, for your process execution, what type of data you store in the memory? You store two types of data. Either the data will be in the form of number, or the data will be in the form of characters. Right? If the data is in number, then you are having two types of representation of the numbers. One is fixed point representation. Another one is floating point representation. Of course, you all know, सबको पता है, floating point representation. If you have fixed point representation, then you can have another two types here. In the fixed point, you can have the number either unsigned or signed. If you have number unsigned, how you represent 5 in binary, you know that, yeah, 101. Very simple. 6, 110. 9, how do you represent 9? 1001. Like this, you represent the number in binary. If it's a signed number, then signed number representation is having three types of representation. What are the three types of representation? First is one's complement. Okay, it's a complement. Then next is two's complement method, and the last one is signed magnitude method. Right? I hope you all know all these methods of representing the number. That's the fixed point number. Then we have another representation, floating point representation. If you represent the number like this, these are the representations in the binary. Let's talk about character. Should we represent character also in binary? Yes. Why? Just because my CPU can understand every single thing in what? In binaries. So I'll have to represent characters also in binary. You don't have direct representation of characters in binary as we have for numbers. Hence, scientists have given some kind of different method to represent characters in binary. Yes, you are aware of it. ASCII representation is one of them. ASCII, ASCII. What is that? This full form mat batana if I am asking what is that. It's just a representation of characters in binary. You know that, yes, you are the student of computer science, you know this, that what is ASCII. So if ASCII is one of the representation or one of the implementation of the characters in the binary, what character representation of binary says, actually how you represent the character in binary, there are two representations here possible. One, of course, I told you, one is ASCII, ASCII, ASCII जो भी pronunciation करना है, and the other one is extended BCDIC. Now see, BCD, you know, right? Binary coded decimal. Binary coded decimal was supporting only numbers. Binary coded decimal, BCD, is only for numbers. If you have the BCD only, that's the only for numbers. So that BCD got extended, and that extension is extended binary coded decimal interchange code, and this extended binary coded decimal is having support of characters also. You can represent characters also in the form of binary. So these are the two formats in which characters also can be represented in binary. Now इतना तो मैंने समझा दिया आपको, मेन डेफिनेशन तो बता ही नहीं. Now I'll tell you what is data format. It's nothing but, data format is nothing but representing the data in binary. Representing the data in binary. So what exactly architectural decision is? In the architecture, I told the data format is given, which means while designing the CPU, while designing the CPU, what happens? You need to decide this. You need to decide this, that my CPU will take the numbers in what format? My CPU will take fixed point numbers in what format? My CPU will take characters in what format? Decide करना जरूरी है. Very very important to decide this. Why? Just because suppose your CPU understands the number in one's complement representation, and you have provided the number in two's complement representation as input, will your CPU give you the correct answer? No. Your CPU might give you wrong answers, incorrect answers. Why? Just because your CPU's understanding of a number in binary is different and your input is in different format. So you need to specify that how your CPU understands the data. Based on that only, when you as user or any other application program will run on CPU, then that program will try to provide the data to your CPU in that format, so that CPU will give you appropriate correct result. So at the designing time, at the architectural time only, you need to decide that my CPU can take input in what format. That's why data format is mandatory to be given on the time of computer architecture. Now let's see how exactly this particular course will be organized. So how I am going to teach this particular course? First of all, I am going to teach you basics. So which is not included in any of the chapters. Right now among all these, there is no any chapter called as basics. Why? Just because agar basics clear nahi hai na boss, so you can't understand anything among all these. So first of all, I'll teach you basic things about computer organization, architecture, computer system, and multiple things. Once the basics are clear, then we will switch to this instructions. So second chapter will be this one, instructions. Then in the instruction itself, this addressing mode comes. So there will not be any extra chapter or separate chapter regarding this addressing mode. It comes under instruction. After that, we are going to go for third chapter, which is CPU and its functionality, its design, control unit, ALU, data path, and multiple things. After that, we are going to go for computer organization, which is the fourth chapter, IO organization. In this, we are going to study interrupt, DMA, and multiple other things. Then we are going to switch to the largest chapter of your syllabus, memory organization. Important also, of course, so many questions asked from this, very large also. Very important. Why? Just because it is having cache, main memory, RAM, ROM, hard disk, and multiple things. Then we are going to go for this performance improvement, how performance can be improved by using the parallel processing. And you know there is a technique parallel processing called as pipelining. So parallel processing, or in bracket I am writing pipelining. If you are wondering why I am looking down again and again, here is the chat I am reading in my mobile phone. All those chats which you are sending me, I am reading in this. That's why I am just looking at my phone again and again. So performance improvement, that will be our sixth chapter, that we will study the pipelining in that one. And at the end, we will cover seventh chapter as data format, in which we are going to talk about only one thing, which is floating point numbers representation. Why? Just because apart from it, you don't have anything in your syllabus for computer science gate in your this data format and arithmetic. So this will be the course I am going to teach you. Why I am going to teach you these things first? Just because without architecture, you cannot understand the organization. So this will be my flow of entire course. I guess you are fine till now. So you need to say you are good till now or not. Good to go further. If you are saying yes, then we will go further. If you are understanding everything, okay, give me a thumbs up, give me yes, no, and then we will go further. So all these things which I told you, all these are here. CPU design means you need to decide between these two types of design, RISC, CISC. अब इसका difference I'll tell you once entire architecture part is completed. Once entire architecture part is completed, I'll tell you what is the difference between RISC and CISC processors. Then instruction addressing mode I have given you. ASCII, if you talk about more detail, 8-bit representation you have for character. Among those 8 bits, you are going to use 7 bits for character representation and 1 bit for parity. Extended BCD IC, 8 bits, all 8 bits are for character. Here, if you will go for performance improvement, there are so many things in performance improvement, how the IO connections are improved, how memory reactions or memory access can be improved, instruction activity, how the pipelining works, this MIPS flops, little bit we will talk about this also. Then IO organization, memory organization. Remember this point, the time reduction is a continual phenomenon. Means Every time, every year, every day, the scientist will always try to reduce the time used for any operation. So CPU will become faster after 2 years from now, of course. Memory will become faster after 2 years from now, of course. It goes and goes and goes on. Check. Further, a question for you. It's an ESE question, engineering services exam question. You need to give me the answer, correct one. Which of the following is included in the architecture of a computer? Bada simple question. Try it. Addressing mode and design of CPU. Try to solve this question. It's very, very easy one. Very, very easy one it is. Come on. Yes, got the answer. Which of the following included in architecture of computer? Addressing mode, design of CPU? Yes, included in architecture. Instruction set and data format? Yes, included. Secondary memory and operating system? No, no, no. It is not included in architecture. So answer will be 1 and 2, option A. Yes, okay. So let's go next. Let's go further and let's understand something else. Why I have shown this particular thing to you, just because this is the thing which were used before the modern day computer architectures came. So this is one of the machine which was using punch cards as input, output, and the program storage. Such kind of cards were used, punch cards. And what was happening at that time? If suppose you wanted to run a program on a computer, you type down that program and you type down that program on a punch card. Now you put that punch card inside this kind of machine and you put another punch card in which you have already typed down the input. So you need to type down the input first, insert it or store it on the punch card, then you give it to the machine. Now machine will run the program on your command, run the program from the punch card, and this input will be taken from another punch card and the another punch card will be having your output. Suppose output is not good enough means your output is erroneous, your output is not intended output. What you need to do, you need to change the program. How will you change? You will take back your punch card of previous program, throw it, you take another punch card and then type down your another program. And this was the manual work which was going on before the modern day computers came. So what happens to eliminate this kind of manual work? A mathematician von Neumann has given a specific computer architecture. So he has proposed a new computer architecture, and what he told, this manual work I am going to eliminate. How what he told that whatever the processor I am going to have, whatever the machine I am going to have, that processor will be attached with one of the memory, dedicated memory. That processor will be attached with a dedicated memory. What this particular dedicated memory will be used for? This dedicated memory will be used to store the program and the data input. Whatever the input you want to fed for the program, that data and all the program's instruction will be stored in this dedicated. And what is the benefit? The benefit is once you type down by your own input machine, the input, the program, and every single thing is stored in this dedicated memory. And processor can automatically take the input, the instruction from this dedicated memory through these connections. And another thing is, suppose processor is generating any output, that output is stored in this dedicated memory. And with the help of IO devices, we can see, or as user can see, that dedicated memory's output means the program's output. Now suppose if there is any error, should I have more manual work here? No, I will not have more manual work here. There will not be any manual work here. There will be the automatic work here. What? IO device. With the help of IO device, I'll change my program and that program will be updated in dedicated memory directly. And from here, their processor can take the program directly. So what happens in that case? Whatever the previous manual work we had, that is eliminated. That is eliminated. This one human architecture was so big invention, so big invention that has been given in 1945-46. Yes, that time it has been given, and that was a very very big invention in the computer science history, that today in 2020 also you are studying his architecture. You know why? Just because all the current modern day computers you are using having this same architecture, exactly same. अब आप you call this processor as CPU nowadays. This dedicated memory you call as RAM nowadays. IO is IO only. So at that time he has given an architecture, and that was too good that still we are following the same. This architecture is known as stored program architecture, or even it is known as Princeton architecture, just because in the Princeton University this has been designed. Von Neumann was a mathematician. He has given the architecture. If you will see the detailed architecture design, this memory is connected with your, this is your CPU control unit, ALU and everything, and input output devices are connected with your CPU. So this was very very big invention, that in fact nowadays today also you use the same architecture in your computers, in your mobile phones. Yes, he did not invent any specific IO device. He has just given the architecture. He has just given the architecture. That's it. The architecture was so good that still we are using it. He has not given any implementation. He has just given the idea. Now see, there is a bottleneck. Bottleneck means problem in this computer architecture, or this von Neumann's architecture. What is that? What is that? I'll tell you. Suppose this is the CPU or your processor, right? In that processor, you want to run your program, and from the memory, dedicated memory, the program and instructions are fetched. So here you have some portion in which you are having the program, means of course you are having the instructions, and then you are having some portion in which its data is written, means the variable and other data required for program execution. There is only one connection between the memory and processor. Processor CPU एक ही चीज होती है. If this is the only bus between processor and memory, can processor fetch instruction and data simultaneously from this single bus? No. Simultaneously, instruction and data cannot be fetched from this bus. That is why this is the problem in von Neumann architecture. If I have written a statement, no, I have not written a statement here, so I'll have to write here what the bottleneck is: the instruction and data both can not be fetched from memory simultaneously. थोड़ा स्पेलिंग मिस्टेक हो गया, देख लेना यार. चलो लिख लेते हैं, इसको कंप्लीट कर लेते हैं. This is the bottleneck. This is the problem in von Neumann architecture. Now here is a question. Yes, here is a question for you guys. Here is the question. Question is what? The question is, suppose if I'm saying you, okay, I'm adding a new slide here. Suppose if I'm saying you that that my processor is connected with memory with two set of buses. See, this is very logical question. Okay, two set of buses in parallel. Now, can we have both instruction and data fetch simultaneously? Your answer is needed here. If you are really learning here, your answer is needed here. Your answer is needed here. No, we are not using the same bus. We are using a single bus architecture, means one control bus, one address bus, and one data bus. This is complete system bus I have explained here. So one set of buses definitely will have all three types of buses: address bus, data bus, control bus, every single thing, separate. This I have shown only a single bus, means total bus architecture. It includes all three types of buses. Here also, the question is, if suppose you have two sets of buses, this is first set of bus, address bus, data bus, control bus, another set of bus, address bus, data bus, control bus. Can processor now fetch memory, instruction and data simultaneously using these two buses? Your answer is whatever. Your answer is whatever. My answer is no. Not at all possible. No. No simultaneous access. You know why? You know why? Just because memory is single. Single memory we are having. Then buses, if you are having two, doesn't matter. Processor can fetch or can send the signal through this bus 1, through this bus 1, but memory is one only. No? At a time, memory can perform the operation of only one request. Array, it's very simple thing. It's very simple thing. You have two mobile phones. Two mobile phones. With one mobile phone, you are talking to your mom. At the same time, if your friend calls you on other mobile phone, can you talk with both the people simultaneously? No. One by one only you will be talking. Right? Simple. So two communication channel you are having, two mobile phone, but you as the memory, you as the operating device can perform the or can fulfill the request of two other requests or two different requests simultaneously. No, not at all possible. So here simultaneous access is not possible. Why? Just because what? The memory is single. Memory can perform only one operation at a time. Only one operation at a time. That is why. So if I want to solve this problem, instead of having only two buses, I should have even memory also two. I should have two separate memories. Means I should have two person to talk to. One is talking to mom, one is talking to the friend. If you are understanding this, see, Pankaj, it's just an example I have taken. That will that happen or not? I'm not taking two buses. I'm just asking. I was just asking you that why we, if suppose we take two buses also, can we read the memory for two different contents simultaneously? And your answer is no. Hence, this particular kind of thing will not happen ever. That you are using two separate bus systems for accessing only single devices. Why? Not at all required. But suppose if you want to read the instruction and data simultaneously, then you need to have two memories, and that was the solution of this bottleneck given by another set of scientists and called as Harvard architecture. Why Harvard architecture? Just because from the Harvard University professors have given this solution. So what these fellows have said, these fellows have told this, that from your CPU, you will be having two memories connected. You will be having what? Two memories connected. And both the memories are separately connected with CPU. Separately connected. This is separately connected and this is separately connected. So this is your processor. This is one memory and this is another memory. One memory is used only to store instructions. So I am writing here we are having the instruction memory and here we are having the data memory. So data stored in another memory, instruction stored in another memory, and two set of buses, separate set of buses will be used to access two set of memories, two different memories. Problem is solved? Yes. Problem is solved. Problem is solved? Yes. Problem is solved here. So two buses and then the bottleneck is clear. Now, this Harvard architecture practically not implemented. Have you heard that in your computer system you have two RAMs? One is instruction RAM, one is data RAM. You have single RAM system only, not practically not implemented much, not used much. So which architecture still we are using? This one Neumann. One Neumann only we are using. Single RAM system we are having, in which we keep the instructions also, we keep data also. Yeah, but the thing is, why we have used this, or where you can use this. This Harvard architecture is not practically implemented for main memory implementation, but nowadays to implement the cache system, this Harvard architecture is used. Yes, for the implementation of cache system, we are using this Harvard architecture in very high end processors. Very high end processors. Yes, possible. Yes, बिल्कुल possible है. What those processors are having? Okay, let me explain you that. So, partially implemented to use this in the cache implementation. I am explaining you. So you are having two levels of cache memories. How many? Two levels of cache memories from the CPU. From the CPU, this is the first level of cache memory access, and in the first level of cache memory access, you are having two different cache. On this level number one only, you are having two different cache. What are the two different cache? One is I cache for only storage of instructions, and another one is D cache for only storage of data. And then on the next level, definitely you will be having single cache, and that is called as level 2 L2 cache. And this cache is unified. Unified means it can keep both. What? It can keep data also, it can keep the instruction also. So this is the implementation of this Harvard architecture in the partial way to divide the cache memory in two different caches, I cache and D cache. But main memory is still same. Further, if you will use the main memory, main memory is single only. This is main memory connection, and main memory is single only. Now another question for you guys. Harvard architecture is also stored program architecture. What is a stored program architecture basically? As I told, one Newman is known as stored program architecture. What is this? The program is stored in memory. The program is stored in memory. So Harvard architecture is also stored program architecture. Yes, this is also stored program architecture. But what is the difference? In one, you are having single memory, and in one, you are having two memories. चलिए, this much is clear to everybody. What is the use of unified cache? Unified cache can keep both the contents, instruction also, data also. So if there is any miss in I cache, this particular cache can fulfill it, or if there is a miss in D cache, then also this cache is used to fulfill that particular miss service. So in the unified cache, L2 level cache, large cache you keep, in which you will keep both instructions also, data also. Fine. Okay. So if you are clear about this much, then let me know so that we can go further. We can decide what is the next things. Okay. For the next thing, I have not planned anything for the day. Why? Just because it's time for you guys to go. And okay, another thing, if you guys are following me on Unacademy, that's good. If not following me on Unacademy, just go there, follow my profile over there. Why? Just because as soon as our chapters will be over here, then I will be having some practice sessions and some kind of revision sessions on Unacademy free classes. Yes, I am telling you, special free classes are there. Those special free classes I'll be conducting for you guys only to give you more and more question practices. Okay, so follow me over there and keep the notifications turned on weekly, or as soon as my chapter will be over, I will be giving you more questions. I'll be solving few more questions apart from the classroom here. And I'm still telling you, if you are still interested in learning in very more interactive way, more structured and organized way, you need to join Unacademy Plus using this code VDEEP10. You will get 10% discount. If you still confused that how to go further, or why or how much time you need to take for subscription and all, you can be connected with me on these social medias. This is my Facebook detail, this is Instagram, this is my Telegram ID. You can directly message me anywhere. I will be talking to you regarding the same. If you have any confusion about how to prepare, what to prepare, and all other things, you can talk to me regarding the same. I can give you good suggestions regarding your preparation plans and strategies also. Okay, so thank you so much. And I always tell to my students that keep learning, happy learning. Keep learning the things, then only you can learn and you can implement that for problem solving. Remember this particular course is tough, so always come live and learn in interactive way. Tomorrow again we will start, and in the tomorrow's lecture I am going to discuss about components of computer, what type of components we have, and then CPU registers and buses and their small details. So don't miss any class. You just come live every day and you will learn lots of things in this particular course. Fine. So till then, thank you so much. Yes, I will provide complete course on YouTube. कब खत्म होगा? चालू तो आज ही हुआ है सर, अभी खत्म करने का टेंशन क्यों लेना? आपका टेंशन एक चीज का होना चाहिए कि समझे कैसे, लर्निंग कैसे रखें। ठीक है, बची हुई चिंता हम पे छोड़ो, हम कब कैसे क्या खत्म करेंगे कि आपको अच्छे से समझ में भी आए, प्रैक्टिस भी हो जाए। ओके फाइन, सो वी विल मीट अगेन। एंड प्लीज वन मोर थिंग, your favorite Mallesham sir is taking class on YouTube on the same channel for TOC, Theory of Computation. He is really master of that particular course, and you need to attend his classes starting from 8:30 p.m. on the same channel. Live, yes, live. So you just talk to him once regarding this particular course, attend his classes, and on the same channel you will get that particular access. All the people who are present here, if you have not liked the video, like the video, so that this particular video will be going to multiple people who are in the need like you people. It's very difficult to find the content, a good content. You were struggling, yes, people are struggling still, so let them know that there is a course. And how you can help in this particular case? Of course you can help. How? You spread the words in all the channels, all the social medias, all the friends group, that yes, this is the course you can attend in this particular channel. Okay, so it's your responsibility. If you are taking a free course here, free education here, then free education will have some kind of payback from your end also. I'm not asking money from your end, but you need to have some kind of things, some kind of terms to be paid, or in some kind of payment you need to give me something. How you can give, what you can give is this, that you spread the words about the classes so that maximum people can join us live. Like the video, subscribe the channel, so that more and more notifications you'll be getting about this. Fine. Okay, so see you again tomorrow at the same time, 7 p.m. daily we will be meeting and we will be learning lots of things. Till then, happy learning. Goodbye, good night.